This is an interesting piece of science equipment called a bell jar, and it's used to conduct experiments about air pressure. It's a little tricky since air is invisible, but here's what happens. So right now there's some air in here, and it has a little base that can go onto it sometimes. So when I pull this plunger down, air comes through here and into here. When I push it, it pushes out through there. So because it has these two little valve things, air cannot go backwards. It can only go here and then out. So here's an example of a little experiment we could do. When we take all the air out of something and there's no matter in there anymore, it is called a vacuum. So why don't you flip to the back of your buoyant force notes and write vacuum observations. So a vacuum is when we have empty space with no particles in it, and it has very low pressure. Since there's nothing pushing, very low pressure. As you watch some air pressure experiments, you're going to be drawing some simple observations. So why don't you draw a bell jar with the tubing coming off? Okay, we'll watch what happens when I remove the air, and we'll look for pressure differences. Before I do anything, the air pressure is even in the jar, outside of the jar, all around. Now, if I put this base on, it's still the same air pressure inside and outside. I'm going to stand it up for a moment while I pull some air out. So air is in here. Now listen and you'll hear it puff out there. So I've pulled a little bit of air out and a little more. Now check it out. The base is now stuck on by itself. So it's tricky because it was invisible, but what happened to the air that was in here? It went out. So now what is the pressure like inside? Lower pressure. So if inside of here, now there's lower pressure. Compared to that, what's the pressure like outside? Higher pressure. H for higher. Which pushes, low pressure or high pressure? High pressure. So it's pushing everywhere, and it's even pushing up on the base. Okay, do a quick drawing of that in your notes. So here's how I drew it. It's now higher pressure on the outside, which pushes. Now, when I open the seal here, remember there's low pressure, no air inside. Air is going to rush in. Watch what happens to the base. Now it falls off because it's like in the beginning when the air pressure was equal. Okay, now let's see what happens to a balloon that is not very inflated. So here's my drawing of the sad flat balloon. Okay, let's see what happens when we evacuate the air. Right now, air pressure inside the balloon, around the balloon, and outside are all equal. So let's see what happens when we get the air out of the bell and create a vacuum. Keep observing as I remove more air. Okay, so now draw what you observe. So now the balloon is much, much larger in there. It looks like something blew it up. Now, did we put air in or remove air? We removed air. So before, how the pressure was the same everywhere, now there's low pressure inside of the jar around the balloon. Did we really change the air inside the balloon? No. But compared to the low pressure we made around the outside of it, there's higher pressure inside and higher pressure pushes. So that made the balloon appear to inflate. Now, when I let air come back in to the jar, now it pushes and the balloon goes small again. So here's a slightly better picture in my notes. When the balloon was more inflated, it's because the pressure inside was higher than the low pressure outside, and it made the balloon expand. Are you thinking what I'm thinking? So let's see what happens when we remove air from the jar. And now, when we let the air come back in. Poor Peep.